welcome to Kinetics. Hello. Hello everyone. Today we will discuss about chemical kinetics. So chemical kinetics, we have to discuss the one topics that is most relevant to CSIR net gate and IIT jam. Okay, that is first order reaction. So we consider that the A to B, okay, A to B, A is reactant where A is reactant and P is product. So all the examinations determined the rate of equation. After that we have to calculate the question. Before we have to consider the concept how to apply those questions. That's why concepts are clear. So determine the rate of the equation. Rate equals to derivative of reactant by derivative of time. Okay, that means reactant minus and rate of product. We have to the rate of the reaction, the dP by dt, it is the positive. Okay, so now consider the rate law, that is k1 is the rate constant. K1 equals to rate constant. Okay, so that is the related to rate equals to K1 reactant 1. Before we have to consider the rate of the reaction equals to minus of dA, that is reactant, dt equals to k n, where n equals to order of the reaction. So that's why we have to conclude that the dA by dt equals to minus of k minus of that is rate constant k into a to the power n. Okay, that is n or that. Okay, nth order. We have to consider the first order reaction, so that's why n equals to 1, that means first order reaction. Okay, so that's why dA by dt equals to minus of k a1 now integrated the whole equations. After that we have to integrated equation. Okay, get integrated equation. Okay, so that is a term, this a term and this a term are both are equations. That's why we have to consider the a and minus k of dt. Okay, and integrated those value. Okay, integrated those value, upper limit a and lower limit a naught. Okay, dA and dt, sorry, a equals to minus of k is constant, so that's why integrated, not formation in derivative. Okay, so that is 0 and 0 to t. Okay, dt. So now the upper limit, we have to solve those, how to upper limit and lower limit case. That's why we have to understood the, in case A to P, product, reactant to product, T equals to, when T equals to 0, that means concentration of reactant is A and concentration of product, that means no reactions, so that is why the reaction is 0. The reactant of the product, formation of product is 0 concentration. Okay, T, when T equals to T, anytime we have to consider the, sorry, A naught, that is the initial concentration. Okay, and after that the time is T, when T A is A naught is A, and product is A naught minus A. Okay, So we have to that's why the upper limit is a to a not to a. Okay, that is the initial concentration and that is the final concentration. That's why. And t is initially t is 0 and finally t is t. Okay, so that's why we have to derivative all the integrated the equations, and that's why ln, okay, ln a, okay, derivative of a divided by a, that is integration value integrated of dA by a equals to ln a plus c. C is any integrated constant. So that's why the limit the formation in case given the limit, so c is constant is not formation. Okay, so that's why upper limit and lower limit a naught k. Similarly we have to derivative the integrated the dt, and dt equals to t 0 to t. Okay, so the ln a minus of ln a naught equals to minus of k t minus 0. Okay, and ln a naught minus ln a concentration of a, that is the both sides the negative value, both side negative multiply the negative. Okay, multiply. Okay, so that's why the that is the positive become positive and that is become negative. Okay, k equals to 0, 0 means t. Okay, and then this is the final equation. Now we have to simplify the a naught by a equals to k t. Okay, okay, this is the equation number 1. We have to the simplify the exponential factor. We have to this ln part, and equation the we have to consider the a naught by a equals to e to the power kt. Okay, and then the a naught equals to a e to the power kt, and we have to or simplify a equals to a naught e to the power minus kt. Okay, that is equation number 2. All the equations are same but look like different. Okay, this is the integral equation of first order first order reaction. So this is the these equations all time use. So remaining this equation remind also, and that's why now we have to find or calculated the half-lifetime
ENV